Okay, looks good.
Yes, that worked. All right.
All right, thanks so much.
Sure. Okay. So for the recording, we just went through the first couple of cells. Nothing interactive yet. All we've done is loaded some data using the H5Pi module. Okay, so we come to the first exercise, and the idea, what we're going to do here is try and zero pad the reference data to the same shape as the undersampled case-based data. So let me go ahead and give you guys some time to try and use the resize tool to make this happen. Any questions? Okay, hopefully that was enough time. Does anybody want to unmute and be a brave soul and potentially give me some instructions? All right, that's okay. So the command is BART resize, and you need to apply it to the reference data, right? So the idea is to call resize. If you recall, resize has only one output argument, which is why I put 1 for the first part. We wanted to resize along the 0th dimension, and we need to tell it how much to resize to. So what is that? Well, that would be the, that would be the 0th dimension of the undersampled data. And the last thing we need to pass is the input, which is also case-based reference. So let's take a look and see if that works. Okay, so we have in fact resized the reference data to match the 0th dimension shape of the undersampled data using the resize command. Okay. So we have a little bit of code to visualize this reference data. Nothing to do here, so I'll just go ahead and run it. Okay, looks like we're taking a look at 12 coils worth of data. Looks like the readouts are along the horizontal axis and the phase encodes are along the vertical axis. And it's very quick to sample along the readout dimensions. So it looks like this data set has all the samples, the full field of, the full matrix size along the readout dimension, as is typical. Okay. All right, so let's now do a root sum of squares reconstruction. And you may recall from the exercise that we can do that using the FFT tool. Does anybody want to participate? Give me a tip on how to do this. Again, the idea is to use the FFT tool, and we need to do an inverse transform, and we need to do a unitary transform. Let me go ahead and pull up options again for your convenience. Does anybody want to maybe tell me how to do this? Go ahead and take a look at the webinar if you'd like. Take a look at the demo if you'd like. Well, I'll give people a chance to think about it. All right, hopefully that was enough time. I'll give people a chance to speak up, but I'm going to have to start calling people out if we don't get some more interaction. Maybe Efrat, maybe I see that you have your window open. Maybe you can help me out here.
Yeah, I think it would be BART.F15.
That's right. Okay, so we assign that to what variable? I guess it says it right there. All right, so how many outputs do we have? Well, just one. And then what would the command be? Well, you said the FFT. What other flags do we need for inverse and for unitary?
I think you need -I.
Yeah,
-U.
that's right. Okay, and the last thing is we need to tell it along which dimensions to apply, right? And what dimensions are those?
Sorry, say it again.
So the last thing is we need to specify a bit mask along which tells BART along which dimensions to apply the FFT. So what dimensions would that be?
If you want 2D FFT, that would be the bit mask of 0 and 1.
That's right. Okay, so we specify that using this bit mask command along with 0, 1. And I think that's all we would need. Let's see if it yells at me. And the input would be, what is it called? K-space ref. Okay. All right. So we are doing an inverse unitary transform. Let's see if it goes ahead and works. All right. Well, it didn't yell at me, so we'll take a look at some images later and see if we got the right output. But thank you. Thank you, Efrat. Okay.
Gopal, one quick comment. I want to say to everyone that we really encourage people to, be more interactive and speak and ask questions and, feel free to participate. That's what we're here for.
Absolutely. And, just in case you missed the very beginning of when I was speaking the last hour, I was in your shoes not too long ago, so I know the pain points and, please do ask questions. This is meant to be interactive. Thank you, Efrat. Thank you for speaking. Okay, so let's go ahead and run the next cell. Looks like there's nothing to do. It looks like we're just visualizing. So let's take a look. Okay, well, these look like images. So in fact, it looks like we did do the FFT along the right dimensions. So let's proceed. Okay. So we have coil images. The next step for an FFT-based reconstruction is to combine those coil images. You may recall that we can do that with the RSS command, which stands for root sum of squares reconstruction. So let's use that tool and try and get our first reconstruction. I'll go ahead and take a minute. I hope everyone's working because I'm going to call someone.
Any chance you could show the help on RSS?
Oh, yes, sure. Thanks for the question. Who was that?
BJ.
Ah, thank you, BJ.
So now you can't call me the rest of the time.
Yeah, get ready.
No, that's my quote.
Well, go ahead. Whenever you're ready, BJ. BJ, are you ready? Would you be able to help me out here?
I'm okay as I go. So I have RSS ref equals BART.
So
And
far,
then
so good.
we have one output, I'm assuming.
Mhm.
And then in straight quotes, I have RSS, and then the $, the sub command for the BART bit mask with 0, 1.
Along which dimension are we doing root sum of squares?
I probably got this one. Actually, is it 3?
That's right.
All right. I'm glad you asked because I put in, and then
What's our input?
and then our input is so we're doing the ref. So there'd be case-based ref, KSB ref, I think, or not. I don't know.
So we're using the images. We are already in the image domain. You're right. It's the reference data.
Oh, yeah. Okay. So CImage ref then.
That's right. All right. That should be okay. Let's see if it works. Thank you. Thank you, BJ.
Welcome.
All right. Looks like we got an image. Doesn't look great, but it does look like a zero field reconstruction. Let's see if we can improve with some model-based reconstruction, some better use of the sensitivities, coil sensitivities, the redundancy across coils. All right. Is there anything to do here? No. Okay, so this is some discussion about the scale factor. If you were part of the webinar earlier, I was alluding to this. So if we have fully sampled case-based data in the center, both in the readout and the frequency encoding dimension, BART's going to be able to calculate the scale factor automatically. In this case, if you take a look at the sampling pattern, do we already have that? Okay, it's not actually clear from this figure. We'll look at it later. In this case, we don't have all of that, so we need to provide the scale factor manually. And the algorithm for that, the algorithm that BART uses is to use that's 99th percentile of the input to set as the upper limit. So this little tidbit of code does the same thing to calculate a scale factor manually. Okay. Doesn't really mean anything other than a scale factor, so we'll just proceed. It's a detail, but could be useful for your purposes as well if you don't have fully sampled data in the center. Okay, so let's next run this plot. Nothing to do here. What is it doing? Looks like we're just plotting the case-based data. Okay. Okay, so we're looking at the undersampled case-based data, nothing to do there. Okay, here, now we get to take a look at the sampling pattern. So, we didn't talk about this command, but it's good to try new things. So looks like we can look at the sampling pattern using a command called BART pattern, not too surprising. So this is a good opportunity to try using the help window yourself. Try using the help, figure out the command, the options that you need to use, and try and calculate the pattern of the sampling mask. Go ahead. I'll give a couple minutes.
Gopal,
Yes.
I have a quick suggestion. Perhaps you could show everyone how to observe the help through the Jupyter Notebook interface by using the exclamation mark. So running the same command, the same Linux command, but inside the Jupyter Notebook, just in case they don't have a terminal that is open in addition to the notebook.
Oh, I see. I've never, okay, so you're saying that if I do a bang,
Yeah.
yeah, BART.
Yeah,
that should make, that's probably going to work, right? So,
yep.
Oh, well, okay, I probably need to make a separate cell.
Yep.
Yeah. Thanks for that suggestion. Yeah, different BART's amenable to different workflows. So, okay, well, we have the help available. Not too many options to take a look at, so it shouldn't be too hard. There is a note here about needing to use the .real command because the output of pattern keeps the type of the input by default. So would anybody like to help me? Let's see. I think I saw, let's see. Natalie, I saw that you responded earlier. Maybe you can step up and help me out here. Okay. Are you able to, well, would you like to speak or would you like to give me the answer on the chat? It doesn't, I guess, it might be more. Yeah, go ahead.
I'm just searching for the name of the inputs, but we just use like BART. We have one because one outputs, then the pattern, then the input parameter. So I don't know the name. It's like
right. So I think you said so far BART one
comma pattern.
Mm-hmm. Do we need any other further options?
No, I don't think so.
Nope, you're right. So, and what's the input?
And something.
So we're applying the pattern to the undersampled case-based data, which
yeah, okay.
right. And that's called. Sorry, I guess I gave you.
And then the point wheel at the end.
That's right. Thank you. So by default, the pattern command retains the type. So we need to cast this to a real. And it looks like we forgot something because we need to output this to something, right? So what do you want to call the output?
Yeah, sorry. It's I don't know.
Okay. How about mask?
Yeah, okay.
Okay.
I agree.
Okay. All right, so we have the mask. The second step was to calculate an acceleration factor. This is kind of what I was talking about earlier, where you know, just using the if you're using the Poisson disk sampling, you should take a look at the R factor output on the command window rather than the acceleration factors specifically. And so basically, this is talking about how does it do that, right? Counting the number of samples that are non-zero. So how would we do that? Natalie, you're on a roll if you'd like to continue.
No, sorry, I don't know.
All right, it's all right. I'll just fill it in because it's not a BART command. So at least I'm not aware of a BART command that does this given a mask. So let's see. We need to calculate all the how many samples, how many elements there are in this array. One way we could do that is by outputting all of the shape of the mask. So that is all of the elements of the array divided by the number of non-zeros. One way to do that I know of is just to do a sum, since it is a binary, and that should give an R factor. Okay. Well, now it's more clear that we have every other line, and in fact that we don't have the center of case space, which is why we needed to calculate the pattern. So the acceleration factor is 2.
Would taking the mean of that mask also work? Inverse, maybe.
Well, we need to calculate the number of elements. If we calculate the mean, what is the mean of the mask? If half the samples in the mask are 1.
It'd be 0.5, so it'd be the inverse of the mean, right? Would give this the same.
That's true. Oh, yes, it would be the inverse. Yes, okay, so it could be, yes, we could have calculated by the inverse of the mean. Yes, thank you. That's a cleaner solution, actually. Okay, so let's see. Who was that? I'm gonna call on you next. Was that BJ?
That was me again.
Okay, all right.
So I don't like how the system works. You should take us out of the rotation until you've asked everyone.
Yeah, I think that would be good. But thank you, BJ. So let's move to the next to do. Now we would like to calculate the inverse Fourier transform. This should be a slam dunk because we just did it, right? We just did the FFT. So how would we do this? How would we apply the Fourier transform to the undersampled case-based data? Mariam, you're up.
Yeah, sure. So you can type CIMG underline undersample UNG equal to BART parentheses
Okay.
1
Right, because there's one output.
FFT and I dash U.
What do the I and U mean?
The inverse Fourier transform and the unitary Fourier transform.
The unitary, right?
And then bit mask of I think 0 and 1.
Sorry. Right, because we need to apply it along which dimensions? Yeah, the 0 and 1 dimensions, exactly. So, and then what's the input?
So the input will be the I lost the track. Where was the image that we calculated? Oh no, sorry, the KSP. So it would be the KSP underline on.
Perfect. All right, that should work. All right, well, we just have the shape. We'll need to take a look at what that image is later. Maybe this is what it, maybe this code will do that. Okay, does this make sense? Yeah, go ahead. Maybe we can continue with Mariam. Mariam, does this make sense?
No.
No? Why not?
It's like we have the shifting of the case space and then.
Well, we're doing the FFT, right? And I think we're seeing some aliasing, twofold aliasing along the vertical direction, which is the phase encoding direction. Is that to be expected if we only have every other line? Yes, it is, because we have every other line. We're not fully sampled, right? So actually, you did it perfectly right. We expect to have aliasing, twofold aliasing along the phase encoding direction, and it's precisely in this sort of situation that we need to do something other than an FFT-based reconstruction to get reasonable looking images. But thank you. Yeah. All right. So next. Oh, well, okay. We need to do the root sum of squares reconstruction. Who can we have next? I see Paul. Paul, could you give me some help?
I can try. Let's see.
Oh, we can do the Efrat's idea of looking at the help. Oh yeah, we already looked at the RSS help, so there's actually no arguments that we need. What's the only thing that we need to pass? Other than the input?
So we're going to try to reconstruct from the root sum of squares. Let's see.
We got to give it a name. What would you like to call it?
RSS recon, I guess.
Sure. I mean, that's maybe RSS is zero filled recon.
Sure.
Yeah. Okay. Oh, okay. Yeah. RSS recon is cleaner. And there's no other RSS recon we need, right? Yeah. So that's fine. Yep. Okay.
So now the idea is, so last time we got that n/2 ghosting because we were taking the IFFT of the sample with ignoring the blanked out line. So is the idea now we're just going to zero fill those and then do the IFFT again? Is that?
So we've already done the IFFT. All we need to do is combine the coil images.
Oh, I see.
So we're not going to remove the aliasing at this point yet. So sorry if I confused. Yeah, I think what I said was a little confusing because I didn't realize we hadn't done the root sum of squares yet. Sorry. So so with that in mind, what's the only thing we need to pass to root sum of squares?
Can we do help RSS?
Yeah, it's right here, right below.
Okay, perfect. Yeah, so I guess the bit mask over the dimensions we want to operate.
Mm-hmm.
And in this case, it'll be 0 and 1, I guess.
So we need to do a root sum of squares.
Across coils, right?
That's right. Yep.
Okay, so that's third dimension, I guess. Yeah.
Yes, counting from 0. Mm-hmm. And then what's the input?
The input will be the yeah, there it is.
All right. Should be all we need. Let's see. Uh-oh, got an error. Why is that? Oh, okay. Looks like it expected this name. So that might be the. There we go. Okay. Looks like they already specified a name. So we need to use RSS undersampling instead of RSS recon. But otherwise, perfect. Thank you. All right. So let's see. We already did the help. Okay, we just needed the coil compression. I guess for how many more cells do we have? Okay, we only have a few more, so we're doing just fine. All right, let's move to the coil compression. Who wants to help me do some coil compression? You got to use the CC command and the CC apply command. We only need to do CC in this first cell. So it should just be one command. I'll give you all a minute. Well, actually, I think it's nice to have the real-time discussion. So who hasn't gone yet? Oh, I think everybody except for the speakers have left. Okay, I guess we're back to DJ. Or yeah, go ahead. Is that right? There's only a few people? Okay.
Oh, that's odd. Actually, this one, I did not pay very much attention during the first part of the session. Well, I mean, we start with a CC matrix because that looks like your preferred variable, and it's going to be a BART command. And I'm guessing once again with one output. And so it's CC. And can you pull up the help for that?
Yep, it's right on the left.
Where'd it go? Oh, there it is. Okay, let's see. So what this data has 12 channels, and we want to. Was it just we just want to arbitrarily compress it? Not arbitrary, but do I get we get to pick how many virtual elements, or did we already decide?
So we don't need to specify that yet, actually.
Not yet.
Yeah, we just need to calculate the coil compression matrix in this cell. We will choose a number of virtual coils, but that's in the next cell. So
Okay. Well, so then we want dash capital M, I'm guessing.
that's right.
And and I guess we need an option. Let's go with dash capital S for SVD.
Okay.
I don't know if we need anything else but an input.
That's right. What is that input?
And so, so this is, we're going to be working on the image data, right? So we would want.
We actually compute the coil compression matrix directly from K-space. Actually, that's an interesting question if you can compress it, use the image data as well. I don't know that, but
okay, so K-space, haha. So we would want the K-space undersampled, I believe.
right.
Let me see.
Okay.
Huh?
Anything else?
Or we're doing this from the, what are the inputs?
Actually, we've completed the command. So I'll just, because look, you actually gave me all the information I need already. There's one output. This is a CC matrix. The options, and what is that? What is the one input? There's only one input, which is the K-space, right? According to this, the outputs are either the coefficients or the projected K-space. Because we chose the -m command, it's going to output the coil compression. The coil compression matrix, which I guess is being called the coefficients here. So
we need to use the full the reference K-space here instead of the undersampled. Is that what?
Right. So another name that's sometimes used for the data used for coil. The data, well, yeah, typically what you have at the time of calibration is the reference data. Could you also use the fully sampled? I think that's less conventional. Usually you use the reference data. So okay. Yeah. Oh, what happened here? Oh, okay. It like saying another issue where there's a specific name it expects. Okay. Yep. Thank you, BJ. Yeah. Okay. Actually, this is nice. They're outputting what is the shape of the coil compression matrix for your knowledge. So that's helpful. Does this make sense? Yes, because well, the coil compression has to do with the coil dimension, and I guess the fifth dimension is now being used as to describe each of the 12 dimensions. It's kind of like a map dimension, right? Like I was speaking before. The key point is that the spatial dimensions are not being used, they're being reserved. So that is the reason for that shape. All right, let's do some virtual coil compression. This is where we have to set a number of virtual coils. I don't know. How about okay, yeah, so they want the non-virtual coils to this be named this. I don't know. Maybe we can do 6, half of them. So what's the command? Let's focus on that. Paul? I guess, oh, that's
Sorry,
not,
I had to find the tab to unmute myself here. Let's see. I'm trying to get an environment working at the same time, so my intention's a little divided. I apologize for that.
Well, I'll pull up the help. So we need to use the CC apply command. That should be helpful.
Okay, so we want to apply the coil compressions.
And it looks like we're expecting the following names from the print command, so I'll help with that.
Right, so
So we can focus on the BART command.
okay, so it's going to be BART, and it's going to be one output, I'm assuming.
Yep.
And we're compressing down to num v coils, so minus P.
Dash P. And we got to give the argument. Several
So I
ways.
guess that's
Yeah, several ways to do that.
$sign.
Python. One way to do that is this. So, okay. I guess
Okay.
assuming if there's anything else, we might have to add something else to the command. Is there anything else we need to add?
So it looks like it needs three inputs that it always needs: K space. I'm trying to read what that says there. CC matrix and projection K space.
The convention to read this is that the last object is typically the output, and the remainder are inputs. I realize it's a little confusing. So actually, there's two inputs and one output. Yeah. So.
Okay. So it looks like we need two more. We need to pass it two more parameters.
Yeah. There's also one more thing we need to do, which is to make sure that we use the same. We tell Coil CC apply which type of compression we used.
Oh, I see. We might as well use SVD. That's what we've been using.
That's right.
So far. Okay, and let's just scroll up to see what the variable name is that we need to give it. Is it the undersampled K-space data we're passing in? Let's just see.
Yeah, well, right now we're doing the reference. We need to do both actually. But right now we're doing the reference data. We're compressing.
I see.
Yes.
So KSP underscore CC underscore ref.
That would be the output. What are we inputting?
Oh, I see. Okay. CC matrix, I guess.
Well, first we need to tell which K space, but yes, the second argument is CC matrix. And for this interest of time, I'll just fill in the second one, which is almost exactly the same thing, except there's a different input argument. Let me make sure I do this right. K space, what was it called? Probably UND. Yeah, I think so. Yes, okay. Okay, that should run. Okay, so everything is the same except we've compressed a number of coils, so that's what we have. Let us continue onwards. Let's take a look at the calibration. Okay, just two more steps looks like, so we're almost there. I see we have, did we have anybody new? We had someone for a second, but then they left. Okay, so let's do the coil sensitivities. That command is eCalib. Looks like we have a little bit of noise. Thank you, Paul. Thank you.
Yeah, sorry, I think that's my mic.
No problem. Yeah. Who are we around to? Natalie, you want to help me with the eCalib command? Second to last.
Yes, okay. So the outputs will be called coil sense.
That's right. I guess you were ahead of me. You read the name here. Yeah.
Yeah.
Okay.
Yeah. Then we use BART, eCalib with parameters -a.
Hey folks, I just want to give you a heads up that you know, we're going to be finishing soon. So
Okay. Well, there's no. Maybe I should. Let's.
So the option is to Gopal, if you want to continue on, that's okay with me. If the other ones, then we'll not close the meeting and just keep them, and we're not going to do a wrap up. So it's up to you.
Okay. Thanks, Mickey. I think it's if you know, maybe people can comment in the chat. I'm happy to stay a few extra minutes if it means that we'll be able to go through this. There's only one more step. Maybe we can do the raise hand thing. If could you please raise your hand if you'd like to continue? Or maybe the way I should do it is raise your hand if you want to conclude. Okay, actually, a lot of people want to continue. Anybody else? I think that's a quorum. I'm going to assume Efrat wants to continue too. So.
Okay, great. So I just want to thank you all, everybody, for participating. I'm going to go move to another room, but just keep going. Go ahead.
Yeah. Okay. Sounds good. And yes, if you know, Paul, no problem. I see you need to drop. You know, drop as you need to. There's only 2 more commands anyway. So. Who was helping me? Was it Natalie? Yeah, Natalie. Feel free to continue.
Yes. So we use BARTs. We have 1 output. Then we use eCalib -a, and maybe we should also ask for 1 map. So -m and 1.
Oh, sorry. 1 second, Bart. What did you say? eCalib?
eCalib -a, -m and 1.
Actually, you're ahead of me. What is the A? Oh, pick threshold.
Automatic threshold.
Okay. Sure. Go. Yeah, that's fine. Okay. And yes, we need to just output 1 map. Okay.
And the input is the caspace CCRF we got earlier.
Okay. And that should be it. Yeah. Does that work? Okay, that's okay. So actually, we get some output of what is the eCalib command doing here. I guess I didn't talk about this during the webinar. I'm actually not really sure what these commands mean, but I'm sure it would say, so I won't dwell on it. But let's take a look at the sensitivities. So, okay, looks like we see some images, and it looks like we also see a little bit of shifting, like what we might have seen, what we were discussing previously, perhaps because of one of the effects that was discussed previously. Mariam and Efrat, you have your hands up still. Would you? Is there a question? No, Efrat, no. Okay, all right.
No, sorry about that.
No problem. No problem. I made that mistake before too. Okay, so. All right, so let's just thank you. I think it was Mariam or no, Natalie. Natalie, thank you for your help. Let me go to the last command, which is the reconstruction. Okay, so I'll give everyone. This is kind of what we've been building up to. So I'll give people a minute to figure out the reconstruction command. Hopefully, somebody will step up to discuss the big command. So yeah.
Gopal, maybe you could open the help of that command just to, you know.
Absolutely, thank you. Yep. Is it actually already open? It is, yeah, okay. We might also need the regularization help as well. So I'll pull that over here on the command window. So with all of that help, we should be able to figure something out. What type of reconstruction are we instructed to do? Okay, we're doing L2 regularization. Okay, nice and simple. We can change it later if we would like. So I guess I'll choose a rate. Wait for somebody to give me a number. Okay, that should be enough time. Who are we around to? Has it been a while since? Well, would anybody like to contribute to the big command, to the exciting command?
Can help.
Okay, Mariam, thank you.
So you need first to define the strength, or would you like to define the strength of the regularization?
Yeah, I think you're saying we have to define the regularization parameter. That is correct. What would you like to choose as a number? Probably something between 0 and 1, since if we scale, it will give a reasonable result.
So 0.05 maybe.
Okay. Let's see how that works. Okay, and then looks like we're calling this recon, the image output. So we'll just call it recon.
BART.
That's true.
1 and peaks. So I, for example, number of iteration equals to, I don't know, 30 or 50.
50? Okay, sure, we can do 50 iterations. Hopefully that doesn't take too long. Okay.
And R type of regularization.
Right.
L2.
So how do we specify L2 regularization? I have it over here, some of the information.
Dash L2.
What is it again? What did you say? It's Q. I hope you. I think you said that. So no, ignore that. We didn't finish the command yet. Q, and Q gets 1 argument, so we'll have to specify that. And then are we done? Do we need to specify any other flags?
We can, but it's not necessary.
Okay.
And then 2 inputs.
So there's one other thing, which is that, remember we calculated the scale factor up here? We need to specify the scale factor to get a reasonable reconstruction with regularization parameters between 0 and 1. And I realized that we didn't discuss that before. So there's absolutely no fault of yours. I'll just pull it up. We talked about the scale factor here. So we need to specify the scale factor as well. What option helps specify the scale factor? I guess that's, yeah, I'll point out, actually I'll point that out because there's a lot to look at. It's this one right here. So how do we, using that clue, how would we specify the scale factor? Well, it's just dash W. And now we have 2 arguments to give it, right?
So it would be
the first one being, we need to actually specify the scale factor as well. What would be the first argument? L2 reg. And the second argument, we need to specify the scale factor as well. No worries. So it's also going to be scale factor. That's the name of the variable that I just highlighted. And no problem. So so we're done with the command. What other inputs? What inputs do we need to give to the PIX command?
So the undersampled case space and the the sensitivity maps.
Right, and we need to use this coil compressed undersampled ones because we also coil compress the sensitivity maps, I think. Right, see, there's only 6, right? Because we compress, so we need to use the compressed K-space. Okay, so what was that called? That was called coil sense. Okay. Let me take a minute to study that myself. I don't think we need this comma. I think that should be okay. And a lot to digest there, but it should be okay. Let's see if it runs. If it runs, we should get lots of output here. So, L2, okay, right. All right, that's just a little syntax error there. Okay, it's running. And it didn't really give any output, so we'll just add a debug flag. This might be useful for you all as well. If you add a debug level, it'll give more output. Okay, so now we got a little more information. We did in fact run it for 50 iterations, like you asked for, Marian, thank you. And we have the output shape. And let's take a look at what it looks like. Oh, what happened here? Oh, we forgot to rescale it. Okay, a lot of outputs, a lot of options to specify. So now we get, actually this was helpful. Now you get to see what happens if you don't scale back after using the scaling, right? So, okay, there we go. So that looks more reasonable. And comparing to the root sum of squares reconstruction, we get to see basically what is the benefit of parallel imaging, which is that if we more carefully include the information about the coil sensitivities, we can resolve artifacts such as undersampling artifacts. And in the case of uniform or alternating, uniform undersampling, it would be reducing aliasing. And that's all we have. So I think we're already a little bit over time, but I'm happy to stay for a minute just to answer a question or two. But otherwise, thank you for staying to the end. Hopefully this was helpful, and have a great day, night, midday, wherever you are, whenever you are. Thank you. Oh, and there's lots of extra credit too. There's a small extension extra credit that you're welcome to work on if you'd like. Are there any additional questions or comments?
I have a question, but I don't know if it's a place because it's on my work. I met difficulties with PIX if I change the version of BART, and I was wondering if you have any idea of what could change a lot. So because when I do reconstruct images with BART 0.4.00, it works very well, but using the very same parameters, but with the very last version, I have like very weird images, and especially like I have only the borders of my images, just like the center of the guy space was like weird. So.
Okay, I'm not sure I completely understand the question, but it sounded like there was, am I correct in understanding that there was an inconsistency based on different version numbers? Is that correct?
Yeah, changing the BART version, because I just wanted to use the very last version of BART to maybe try new features. Mm-hmm. And I cannot reconstruct my images like properly yet. And maybe I'm missing something which change between the version.
Yeah, well, if I were debugging that issue, I would first take a look at the release notes for each of the versions and try and compare the release notes of the version that's working versus the one that's not, or working better. If that's not providing the information I need, the next level of debugging I would do is to run a diff, which is very easy to do in Git because BART is entirely version controlled. You can run a diff on whatever command is causing an error or commands. And if even that is not helping, it might be a very detailed issue. And then the last resort is to examine the source code, and that is all accessible as well. So that's the order in which I would take to try and debug that. But it's probably something minor that you can probably just figure out from the release notes or a diff.
Gopal, can I add something?
Go ahead.
So Natalie, I think you mentioned that you were using version 4 previously, and now you're using the most recent version, which is 7, right?
Yes.
And so yeah, so there have been a lot of changes. Version 4 is really outdated by now. And so what I can suggest to do, in addition to what Gopal said, is to send a message to the MRI.recon mailing list. And you will, if you could please specify the error message that you get and exactly which version you used previously and which version you're using now. And then you'll get help from John and Martin Ucker, who are both the original developers of the toolbox, and they're highly familiar with all the versions. And they would know, or at least they would be able to direct you more into how to change your command or the things that you're doing. Because I do know that BART-Pix was changed significantly after version 4. So perhaps you run into some issues related to that.
Okay, I will write an email. Just like, I don't have any errors, just weird, but okay, I will send an email.
Yeah, so in addition, so you got some great suggestions from Gopal, and I think also, addressing the mailing list would be helpful both for you and for all the other users that can, maybe they run into the same issue and then they can see the answer.
All right. Okay.
That's a great point, Afra. Thank you. Any other questions? Last questions? We are over time, but if anything specific to the exercise. Okay. If the answer is no, thank you again. Please use the listservs, interact with us. We're trying to make things as accessible as possible with things like the webinars and the help resources, and stay tuned for the next webinar. Okay, thanks.
Yeah. All right. Bye. Thank you everyone for coming. And the solutions and the recordings of the webinar will be posted on the BART website soon. So you can download the answers from there.
Thanks everyone.
Thank you again. Thanks Gopal for this great tutorial. It was really excellent.
Thank you.
Gopal, how are you doing? You're muted, by the way.
Okay, I'm muted. That makes sense. Entered a different room. We should probably close the meeting and then join group meeting, right?
Yeah.
So,
yeah.
Okay, take care.
All right, see you there.
Bye.